Let's give it up for the Dinero guys.
Woo! 2 seconds, then I will get it. There we have it. Yeah. Okay. Hello, my name is Mikkel. This is Per, and we are coming from Dinero. We'll start by doing this. Just talk about who we are. I will talk about that Per is a front-end developer in Dinero, like me, and he has some experience in front-end the last 2-3 years, and sitting with that. And that is his Twitter, and he's trying to do some tweets, but please follow him. So,
yes, thank you. And this is Mikkel, and we're working together in a team of 2 front-enders in Dinero. Mikkel has also been working for DFDS and DanaWeb before Dinero, so there's a bit more experience there. So yeah, that's his Twitter.
Yes. Yeah, we're coming from Dinero. Dinero, I don't know how many of you know Dinero. Okay, a bit. Yeah, it's a small accounting system that primarily freelancers and so on uses. But actually, we have some of the stats. We actually have 64,000 active users. So it's kind of many users we actually need to work with and to please without destroying the experience that we have. We have the higher payment rate than Spotify. And we have an NPS that is higher than the Apple iPhone. So that's kind of the numbers that we trying to work with when we're designing new software, new stuff in the application. And that's about Dinero. But please come and talk to us. Yeah, sorry.
What is
NPS is a Net Promoter Score, which measures how, basically it's how much you likely are to recommend the program or stuff you're using. So it's, I think it's, what's it, 73? I don't know.
Yeah.
I think it's around that, but it can also be minus, so it's, I don't know the scale, but it's pretty high, I think. Yeah. The progress from Dinero for around 2 years ago was that we had a big monolith, and that monolith was built in .NET as the backend, but Backbone as the frontend. And the idea was to do some new stuff, do some more advanced stuff for the more advanced users in Dinero, but also do some more niceness on the stuff that Dinero has made. But we could not do that in Backbone because Backbone was tightly coupled with the backend in .NET, but also that the whole system around Backbone was pretty much custom, so custom model binders, all that stuff that actually destroyed the possibility to actually do anything without doing a risk on the whole application when you edited something. So we actually decided to go on a new framework, decided to go with Angular. And the reason we chose Angular in the end was actually just because we like Angular. We did some performance analysis on something with React and so on, but in the end we actually liked Angular because of the syntax and the way you work with the components and views and so on. We actually had one developer trying to use Elm, but that didn't work for us because we had a designer at that point who made all the HTML and CSS for us. So it was actually quite hard to actually just implement in Elm because you need to write all that in Elm. So that's why we didn't choose that. And also because he was the only guy who actually knew Elm. So a little talk about how we actually got to the new front end, because actually today when you're using Dinero, you don't know whether you're using the old one or the new one. So the idea was to make a transition over to the new front end in some way without doing a big bang release, but also without annoying the users. So what you actually see today is actually the similar views, the similar UI. We designed something new pretty soon, but actually it's 2 different front ends. So one is Backbone and one is Angular, a full Angular SPA. And the way we actually do it is that we had a lot of progress with this, but the end solution was that when you access a URL in the application, we have some rewrite rules in our web server that actually configures how you're going to end to either the new frontend or the back or the old frontend. So we have the rules that says when you use go to that URL, this one, for example, then the rewrite rules tells the URL to actually request a index file, and that index file requests a build number and a CDN that actually have all the build files for that particular build. All this stuff is built like with the Angular CLI. So we're using basic Angular CLI to build our production and so on. And then we just take the index file from that build and put it out as the root, as the new master of this production build. And then the URL redirects to that. Yeah, and that's the file under that build. And in the IIS, which is our web server, we actually use it like this. So you can see that we request a URL, and then we match that path, and then we're just pointing to an index file, which is switched every time we build. So this is actually the way that we're switching from the new frontend, or from the old frontend to the new frontend. So you can maybe see some, if you're using Denero today, you can see some glitches that if you go into vouchers and create a new voucher, then the flow is quite seamless and you have the SBA experience, but then you click on invoice and then the whole thing reloads and so on. So that's the stuff we have today.
So how much of the site is running Angular today?
I will guess about 30%. That is. So we started taking some of the big stuff that we needed to create at that point, and then we tried to move all the stuff that we needed to add more features to, and then we have created some new pages, some new features. So it's like all the old stuff that we haven't touched in a long time is still the old, because we don't just want to rewrite it just to rewrite it. We actually want to have a. Sorry?
So all the parts I use today.
Yeah. Yes, then we will have some examples of our experience. Is this important? Yeah.
All right, so I think that was enough of some DevOps stuff. So let's get into some Angular. And you might, I think most of you know the track by, but I have made a little example of why it's really important, and show what could happen if you forget to use this. So what I put in that here. All right, so I made a pretty simple example here with the virtual scroll. The virtual scroll is not that important, but it's because of the example I'm speaking out of is we had to make this feature, which is a ledger, and it's basically lots of lines, and you can add lines, and you can delete lines, and you can interact with these lines. So when you have this, and yeah, of course.
Is that fine or more?
Is this okay?
Yeah, that'll do.
Maybe. Okay. So if we have a look at how we do this, this right now, if you look at the console, it's going nuts because basically when we have a mouse enter, we have a immutable list. So we do a copy of the list and we do a copy of the item. So this way the Angular says, all right, I have to re-render this, and it re-renders this item and it makes a mouse enter again. So this keeps going forever. So one way to tell Angular to kind of identify the item and to not re-render this all the time and re-render the whole list is to simply add the track by. And this is really simple. It's kind of hard to code backwards. Here. So we just tell it to use track by, and we have to give it a method to use. So we do track by fn as an example, and we could go down to our component. Public track by. Oh. by function. And the item from the list is passed to this function. Let's not care about the type right now. So we will just return the item ID. So this way, the track by function will tell Angular how to identify this item. So you should you should definitely do this if you have some interaction with a list, and you emute this list. This could come from a store like ngAarhus or something like that. Then you should definitely do this. So if we try and save this, and we have a look again, you can see now the console. I know it's really small. It's down here in the corner. When we hover, it just does the console whenever we put the mouse here, and that it doesn't keep going because it knows, all right, I did what I had to do. There's no more changes, and also they don't stay blue. So yeah. Yes. Oh, not this one. Well, yeah. All right, so the next example is not that much of coding, but it's more like an example to show what really happens if you use a store and if you don't use a store. So we made this this code example, which is the same basically, but one of them has a store and one of them doesn't. And especially if you have a lot of interaction with your backend and maybe some asynchronous stuff, and the user can do stuff while like you don't necessarily disable the whole UI just because you're loading something. So you want to be consistent in how to manage this. So an example could be that we change this number, and this number is fetched from the backend. Or we can disable it, and it will just say it's 0. But if we add something here, we get 10. Like, this is bad. I don't know if maybe we should have done this in English, the example, but this is how it is right now. And we can also disable this, and it will get to 0, and we can enable it again, and it has to fetch again. So the component is, in this particular example, this might have been okay to not use a store because it's fairly simple. So you don't always have to use a store. This is not the point. But if we look at this, we can see that we have an amount change. This is when we change this value. And we have to do this calculate the VAT amount. And this calculate VAT amount actually goes and see, all right, is this item low VAT? If it is, like, we just have to put 0. And if it's not, we have to go fetch on the service on the backend. So this is not that nice to look at. I mean, it's okay. You can. This component is fairly simple, as I said. So it might be okay. But if you start to have like child components or other stuff which uses the same kind of data, and you have the inputs and outputs everywhere, it can get a bit noisy, the code, I think. So that's when it could make sense to like begin to use a store. So if we look at the example with the store, and this is the same, but if we go into the component, we can right off the bat see that this is way more simple to look at the component at least. But we also see that we have a lot more of setup to do this. So this is like the pros and cons, I think, and you have to keep this in mind whenever you decide to go with a store or to not go with a store in your modules. So this is fairly simple. We just have the store and we dispatch these actions on what we want to do. So I think the effects file is the most interesting here, because this is where we really interact with what the user is doing or handle what the user is doing. So let's say, for example, that we changed, when we press on this button, we changed that whether the item should include the VAT or should not include the VAT. And I think that when you're using or you're making your effects, it's really important to have a really good name of what is this effect doing. And it should not do more than one stuff. Like it shouldn't be like do this and this and this and dispatch like a million actions, because then your effects is just noisy instead of your component. And that's not a win in my opinion, at least.
So we have this fairly simple effect right here, which just listen on when the user clicks on this button, and we say we only want to go further in the stream whenever this is true. And when it is, we just go and say update the item, and we have the item ID in the payload as well, and we just set it to 0. So this is, if you remember from the example with no store, what it did with the if else. So this is the same as this one, but it's reversed here. And we take the amount and we update the item. So you can kind of give the effects each their responsibility in the code. And also kind of neat stuff you can do is the stuff where we had to recalculate the totals which were in the button here. We can just say whenever some amount on any item is updated, we have to recalculate the totals. Or whenever any item VAT is updated, we have to recalculate the total VAT. So I think you can really give the effects each their responsibility and make them really easy to kind of understand and read. So yeah, I think that's what I wanted to say about the store versus no store. And
Can you shortly explain what a store is?
Yeah, of course. Sorry. Like a store is the store I'm using here is ngAarhus. It's a Redux library which basically is a way to store whatever data is in your application, but keep it away from the components and modules. Like it's an external way to kind of store it. It's basically an JSON object which sits there, and you can modify it through your actions and events, so to speak.
So kind of a service layer, or
It's your application state.
okay.
Yeah.
All right, and that can be modified by the effects.
Yeah, well, the effects is a way to handle side effects for your actions.
Okay.
So let's say I emit an action, and usually you would have like a reducer to kind of modify the state. But you also want an effect to maybe speak to the backend or emit another action, or so you have these side effects, and those are these. I'm sorry for not explaining that in the start, but yeah.
Yeah, all right.
Cool.
Yeah, thank you.
Yep. Any other questions?
So, as I understand it, that's best for a large scale app.
Yes, that's I think was kind of where I was getting, is that if you have really simple components, as you can see, you have a lot of more setup, and you also do have to set up some store in the main root and so on. You can use other libraries than ngAarhus, which might be simpler to use, but yeah, you have this extra setup, so it might not be worth if you have really simple code to do.
I've also heard people talking about an observable service, just a shared one.
Yeah.
You can use that as a
Yeah. This is
Yeah,
basically what
exactly.
these libraries do. So you can, if you have a real simple example, you can do that as well by yourself using a behavior subject or something like that. Yeah. Definitely. Yes.
We
Cool.
also do it in sorry.
Do you use ngAarhus at
Yeah.
Dinero?
Yeah, we
Yes.
use ngAarhus in mostly all our modules in the application. Some modules, like saying that is maybe more simple, like you have a list of contacts. That list of contacts, you can interact with it, you can just see it and click on it and be redirected. So there's no need for a store, there's no need for the state to be updated and so on. So at that point, we actually just have a component that has a resolvers for the root, and it just fetches the list for the backend. So we don't need a store in that module, you can say. So it's like we're taking the decision each time we're actually making something new. But yeah, we're using ngAarhus a lot in the now.
But you're careful about what you put in the store.
Yeah.
Don't
Yes.
want every piece of data to go through the store.
No.
Necessarily.
No, definitely not. I think that can make it confusing.
Yeah.
You have
That's
other
not the
forms,
point.
for example.
Yeah, we do.
We only have the data model in the store. So let's say you have a voucher you want to create or edit. Then we only have the voucher and the voucher amount and description, but we don't have information about the description, validation, and so on in the store. That's in our opinion, not something that the store should know about. That's side effects of what this entry in the data model is. So that we use effects for and so on as services. So yeah, our store is actually quite clean, the data in the store, but we have a lot of effects and so on around it. Yeah, I think, yeah.
So when you say data model, you mean the data you get from the database?
Yeah, for the backend, yeah.
So that's what you fetch from the defaults and just put right into the store?
No, not exactly. It's actually, sometimes we do, sometimes we don't, because the data model from the backend is actually quite bloated with stuff that we actually don't need for actually in the front end. So in many times when we have services to fetch for the backend, so we have an action that dispatches, let's say we want to get all the vouchers, or let's say a voucher. Then we have an action that dispatches that, then we have an effect that listens for getting a voucher, and that effect calls the service to fetch from the SSP. And then inside that service, we actually map that data model that the SSP comes with to the data model that we want to handle in the front end. So we only save the data model that the front end is cared about. So we don't have that bloated state because we have a lot of entries in those models. Yeah.
You put lists in the store ever? Like a list of the invoices or whatever?
Yeah.
To work
Yeah,
with?
we do that. Yeah.
Okay.
We have that, for example, in the ledger, the example before with the track by. That was our first task to do in Angular. We needed to create a ledger that could handle 1 million items. It's quite hard when the Chrome cannot render a div more than max height, so it couldn't be 1 million items at least. But it can handle thousands of items, and we save that list inside the store, and then we mute that list. Yes, I'll jump to the next example. Yes, we have come by in Denero and we're creating these views and creating these new layers that we needed to wait for multiple data sets to actually being able to work with the view. So let's say, again, you want to create a voucher, then you need a list of contacts and you need a list of accounts and so on before you can create this voucher. But it shouldn't block the view from being rendered. If the list of contacts fills, then it should just render the view and then show a label under the select box that couldn't fetch account, click again, something like that. So we needed a way to actually have this ngX store around it, dispatch some actions to load contacts, accounts, and so on, and then wait for those actions to complete. And we have made an example of that. So we have a little meme battle. So we have a meme component, which actually just the two image sources, where this is simulating that we have two different endpoints, and we want one meme from one endpoint and one meme from another, and then we want to wait for those memes to be loaded before we render this view. So we have again a store and all the setup for the store, but what's important here is the resolve for the view, for the meme component, and that actually just emits two actions to get the two random memes from two endpoints. And then we're actually just waiting for those actions to complete. So we have an action, if we look in the actions file. We have an action to get a random Pepper meme and get a random Dutch meme. And then we also have actions to tell us whether it succeeded or it failed, and so on. So we're actually listening on those succeeds and failed in our resolve to being able to wait for the component to load until we have this data. So again, we're waiting for it either to be successful or failed in getting this image, but we need to wait for both of them to be complete. And it just loads the component. I think we actually in the service have a delay after getting the images. So after 6 seconds it should show, I think. I don't know. Yeah. So in that way, you can create a resolve for your root, for your component that can wait for 2 different actions or more data sets to actually complete and wait for that. So we started with just having waiting, actually like you said, having a lot of properties in the store saying Pepper meme loaded, for example, and so on, and that just bloated the store with stuff that we didn't need. So we just need to listen for the actions being dispatched. So yeah, that was it. Questions to that? Yeah.
It's a bit unrelated. How do you handle concurrent users editing the same invoice?
Yeah, that is actually also a part of having a store in our case. In the backend, we have something called timestamps on the data models. So the timestamp actually is something that is posted each time you update or create something. So when you, let's say you are editing the same voucher I am, and you're saving it, and then I'm trying to save it, then my timestamp is later than the newly created or updated one that you did. So we're actually waiting for that information to happen. So we're saving timestamps on the data model in the store also. So that's the way we handle concurrent users.
So who wins, last or first?
First. Yeah. Then we have a little Kahoot. So if anyone wants to join, you need to take your phone out and just go to a URL. Yeah. I think that's... And we actually have some prizes, I think.
Yeah.
Well, start with two. So I think, is everyone ready? Or is something missing?
I think we're good to go.
Everyone is there? Then we start. Will change detection render this component?
Re-render.
Re-render, sorry. Okay. As I think we're explaining each one. The reason why it won't re-render this component is because it's fairly static. It doesn't have any dynamic things, dynamic values. So Angular actually knows this. So when Angular do the AT of this component, it will actually just have the create element create stuff that it does. So it doesn't need the whole change detection around it. So, and the reason why we're taking these examples is actually something that we have hit in our development lifecycle of Angular, because we started doing these components and then thinking, oh, we have this static, but we don't want it to re-render, so we're injecting the change detector ref and detaching and all that stuff, and it doesn't matter because it doesn't re-render. So, we're taking the next one. And Orlando is first place. Who is that? Ooh. You're about to win a coffee mug. Will this component fail when it renders?
All right, cool. if you show the media. So the thing here is it's a bit tricky, and it's the whole reason why it does fill is because of this integer on init. So we're trying to get this view child of the image, but the DOM is not accessible right now. We have to wait for after view init. So right now this is undefined, this one. So yeah, that's why it fails. It doesn't know source of undefined. I think you have seen that error sometimes. Cool.
Questions to that? If you have any questions, just ask. The next one. Orlando still. What component will be rendered? I don't know if I can zoom in maybe. Two right ones. Okay. So the reason why this won't be rendered is because of one thing, but the A component will always be rendered because it's the parent component. So that will always be rendered. That's just a tricky one we added. But the reason why add_girlfriend component is actually being rendered before add_last_girlfriend is because the params in the URL is not constrained to anything. So we don't tell it it should be a string, it should be an integer, something like that. So last will actually, this root will think last is a name. So we'll hit this component before it hits that one. So you need to actually switch them if you want to hit the other component first. We have made this mistake a lot of times. The next one. And still Orlando. How will girlfriend component be aligned? It's this little tricky CSS spørgsmål. Okay.
Good job.
Good job.
Show the media.
Yeah.
All right, so this is of course also a trick question, but what happens here is that we have the display flex, and it has a width and a height, and this one will be aligned to the top left. But inside this component we have this template which has flex end, but this doesn't really matter because the flex is having this as a child, not this one as a child. So yeah, this doesn't matter. It's like, yeah, it doesn't do anything. So they will both be in the top left.
Yeah. So you need to remember that when you create components in Angular, that if you needed to style Charles and style Charles component like this, you need to add the style to the components and not, or at least to the host inside this component.
Yeah, you can do that.
Next one. Who made most errors this year? I'm Mikkel. Yeah. That's correct. There's no media. Taking the next one. How will the following effect behave? HTML, right? That's okay.
Cool. All right. So what happens here is that we have this effect, and the effect here expects from the stream an action to dispatch. So if it doesn't tell this effect to not dispatch the to not expect an action, it will actually fail. But the stream does reach this code, so this is executed. This does happen. You will get the cookie, but right after that, the effect will say, I don't know what to do with this. It doesn't get anything from the stream. So yeah, A fails, but B is also executed.
Yes. What happens when server-side rendering this SVG? Right? The reason why it actually fails is because of this URL. So when the server side is trying to render the HTML, it will try to reach this code and it will try to execute this link, and the server will fail because of that. I actually don't know why it does it, but it's kind of strange. So the way to fix it is just to remove this. It's really annoying. The most annoying thing is that it doesn't tell you that is it. So we sat for a day and looking through the code and understanding why it rendered on the client side but not on the server side and so on. But actually, the URL was a part of that. We also tried to change it to HTTPS. That didn't work. So I don't know. Yeah.
There's some attribute or some directive you would in some cases have to put on the SVG for Angular to recognize it as an SVG element.
Okay.
So maybe that would help in some way.
Yeah.
I can't remember
Maybe it
the
could.
name,
Yeah.
but I had that problem at one time.
Yeah. Cool. And I think we're to the second last question. What is the order of execution of resolvers and guards? Yeah, sorry.
We have a minute.
Nice. And just to quickly explain this, is that guards all the way down the three of the roots is being executed before any resolvers all the way to the top. So in our case, we experience this because we are making the new front end but still supporting the old one. We have just a user context that we need to load when you access the new front end, and then we need to check on that user context whether the user is our pro user or not, and so on. So if you have a guard down here that needs to check whether the user is a pro, and then we can't get the user context in the resolver here because it will hit that first. So in that way we experience that. So remember, guards always executes all the way down before anything. And the last question, and maybe Orlando is winning amok, I don't know. What will max price be set to? And this is two different interceptors. One is in the root module and one interceptor is in a lazy loaded module. 2 right.
All right, so yeah, to just quickly go through this. This is perfectly fine. This is perfectly fine having the interceptor in the root, but this is not possible. So this doesn't matter. So it's 200. Yeah.
Yeah.
I don't even think we had this, but I'm not even sure if it failed. Like just nothing just happened.
Yeah.
So we were like,
It
what
doesn't.
the?
Yeah.
But if you go to the interceptor documentation on Angular.io, it says that lazy loaded modules can't have interceptors. So yeah. Hmm?
And now it's fun to see who is winning. Alando! Let's give him a hand. You're winning a terminal mug and a Dinero coffee mug. Here you go.
Thank you.
Yeah, that was actually it. We don't have anything more, I think. So yeah, thank you. And if you have any questions, just come and grab me and Pierre. We love to talk to you. Yeah.
Excellent. So, sandwiches have been put up over here. We will do, I don't know, 2 minutes or something, or whenever. I'll start shouting and then we'll be back. Grab some.
Thank you very much. For those of you who were here the last time, not here, but at Kona, I was the bartender there, so I hope everyone was happy about the drinks. I am not a bartender, though. I am a front-end developer at Kona, and I've been there for like a year now, and before that I did full-stack development, so, but I fell in love with the front-end, and I'm very passionate about it, thus bringing me to this talk about what we can do with web components here today. Side note, I drink way too much coffee. I think that's like something we do in this field of work. Yeah, so you can find me on Twitter at InSanityK. I don't tweet that much, but I do follow a lot of people, and I do read a lot on there. Spend way too much time in there. Right, and what I want to talk to you today about is web components and what common problems we have today. What do they solve? And then a little bit about, you know, how are they made up? What is this web component spec, and how does it fit into how we work? And then the flavor part in the title, that'll be like, how can you get started with the framework you use today? And this being in ngAarhus, there will of course be something about Angular elements in there as well. So one of the things here is that we don't want to rebuild components like for every framework out there or for every major version we get, and we want to ship less bytes to users. And especially now with all these mobile devices, this is getting more and more important. And depending on where in the world you want to deploy your code, it's also equally important. And then of course we want to stay productive. You know, no one wants to rewrite their code every day. It gets boring and it gets tedious, and it's not a lot of fun, right? And one of some of the current problems in this spectrum is sort of like what you call UI libraries, right? So everyone has probably spent time with one of these, like a multi-select. This is a Bootstrap one, but there are several kinds. And one of the issues here is that if we look up on npm, this is just a search for multi-select, we get like 400 packages here. A lot of them, of course, a lot of people build their own packages, and that's pretty cool. Open source is great, but there are also a lot of wrappers, and there are a lot of versions in the different libraries, right? You have React versions, you have Vue, you have Angular, AngularJS, and what have you. Not looking into the frameworks, we used to do something like this before, right? Back in the jQuery world. We have our script, our arbitrary library. We have a select class in this example. And then a script, right, where we find this element, and we initialize our multi-select with a few options. And then we have our frameworks. Maybe you've built some of these, and maybe the framework has an implementation of it already, or we can wrap the implementation from before, right? So this is an Angular example, pretty basic example, where we have in the ng after view init, we initialize this multi-select on the native element. A lot of these libraries out there, they do this where they wrap like either the older jQuery implementation or a vanilla JavaScript implementation. And that's all great, but say you have a React version and an Angular version, they might have implemented it differently. So if you come from Angular over to a React project and you're like, okay, this multi-selector is pretty cool, why can't I use that in React? And then you find the version in React, and it might not have the same API, or might not even have the same look and feel. And this is actually true for several other libraries, right? The npm example before, if you search for date pickers, there's like 1,300 results or something like that. I don't know who builds all these date pickers. I've never built one, and they're quite hard as well. And to sort of get into this whole web component thing, wouldn't it be cooler if we could just do this, right? Just declare it in our HTML, and we would have this multi-select, and we wouldn't have to think about, you know, like, how does this work with Angular? How does this work with React or Vue? We could just bind to it and just use it in our DOM. And this is where web components come in, right? Web components are sort of like an umbrella spec, so it covers a few different low-level APIs. And we're going to go through them just quickly here. We have custom elements, we have HTML templates, and we have the shadow DOM. There used to be a fourth as well, but it's sort of died out, so I'm not going to go too much into that. But let's start off with the custom elements. This is really like the meat of web components. They're actual HTML elements, meaning like the tag I showed you before, like the tags you're used to with your Angular components directly in the DOM. It's actually these we're building with this custom element spec, right? They extend the default HTML element class just like every other built-in element you have in the browser. So like a paragraph would be an HTML paragraph element, I think it is, which gives us a lot of cool stuff like the whole DOM API, query selector, and what have you. And then we get lifecycle events like we're used to from, say, Angular or Vue, like our ng on init, our ng on destroy, and the equivalent ones in Vue as well. And just to have a look at what this would look like. So here we have a class, and we're extending the built-in HTML element. If we define a constructor, it's not required, but if we use a constructor, we have to call super. This is what wires up the whole DOM API and the HTML element. Then we have the connected callback, which gets called every time you put this DOM node in, every time you put it in the DOM, your component. So this would be where you fetch your required resources, etc., to set up event handlers, and render your components as well. Then we have the disconnected callback, is where you do your cleanup. It's like the equivalent to ng on destroy, right? This is when your node gets taken out of the DOM again. The third one here on the screen, the attribute changed callback, it's a little different, right? But this basically gets called every time an attribute on your element changes. That could be a custom attribute you've put in yourself, but you could actually also listen on style and class if you wanted to do that. And it only works for observed attributes. So if we have a static getter with an array, we can define the attributes that we want to listen on. So this is like setting up the listeners, like using input in Angular as an example. And then to wire it all up so the DOM understands it is, we call this window custom elements define. Then we give it a string of our tag, and there has to be a dash in there. It would complain otherwise, and that's because tag names without the dash are reserved, like for the browsers, for the DOM, for whenever they introduce a new element or the likes. And then we give it our class, meaning that then it knows that, okay, every time I find this tag in a DOM, when it goes through, then it knows it has to instantiate our class, right? Pretty simple, and it makes a lot of sense. The next one we have are HTML templates, not directly tied to this, but can be used outside as well. They're like HTML or DOM fragments. So they're pieces of HTML, they're pieces of DOM, but they're not actually rendered at first. Nothing actually happens to them until we do something with them with JavaScript, like cloning them, which is actually like incredibly performant. Instead of just taking the element and then copying it in, then when we use clone node, it does it very performantly as well. It looks something like this, right? We have a template, we have an ID, and we have some content inside this template. And this won't actually activate until we grab this template by ID and insert it into something else, right? So this is just an empty, or to the DOM, it's just empty, right? Third one, and this is a big one as well. This one actually, I think someone said that it sort of fixes DOM and CSS. And that's a strong term, but it's isolated DOM, meaning that we basically have, like, if we had our component in a shadow DOM, then the outside world wouldn't know about it, right? Like the video player we have in the browsers, like you've probably seen before. It has scope CSS, and this one is a really big one, right? Because we have all these, we have it in Angular already, right? Where you can define the view encapsulation of your components, where you can say, you know, it's scoped. And then Angular, when it compiles, put on all these attributes to make your specificity on your CSS classes, you know, more specific, so they don't bleed out. But on the other hand, they don't actually stop the outside world's CSS from penetrating your component and you know, affecting it. And this is where scope CSS is pretty cool, because nothing bleeds out and nothing can penetrate it. And then someone might say, but what about if I want something to be changed? And that is not actually part of it right now. I know they're in talks about like a parts spec, I think it is, in the shadow room, where you can pretty much define, like, say, okay, this part of my shadow elements here, you can style that and do something with it. But I don't know how far they are with it, but it's coming. We get composition through the slot element, works a lot like ng content and slot in view, aptly named the same thing, meaning that whatever we put in the tag out in the DOM, we decide where we want to put that within our shadow DOM, like within our template. That could be, in the case of a multi-select, it could be the label, right? Like where do we want to place that? Or it could be all the options and we want to place them in like this drop down. And by all this, we avoid these naming conflicts that we usually get. Naming things is hard, and especially in CSS. This is why we've invented all these ITCSS, BEM, stuff like that. It looks a little like this when we create a shadow root. We have an element, in this case just a standard header, right? And then we attach the shadow to this, so we get this shadow root, which is actually a node just beneath our other elements. And then we set the inner HTML of the shadow root, and then this H1 here is actually hidden away from the outside world, meaning that styles from out there won't bleed in, won't penetrate and do anything with it. So all these three things combined give something like this, and I hope it's you're able to see it out there, right? Yeah. So we have our template, right? We have some styling in there, and we have a div, and I know this is very simple. It's just to sort of keep it within this multi-select idea, where we have our multi-select dropdown, and I've used the slot in there as well. We can name the slots, by the way, as well, just like we can with the ng content, just as a side note. And then we have a script down here where we get our template right by query selecting it. Then we define our custom elements, multi-select here, and we're just doing it with an anonymous class in this example just to fit it on the screen. And then in the constructor, we attach the shadow root, and we clone a node from our template. And that's pretty much it. Like this is a web component, and you could take this and you can use our multi-select like directly in a DOM, and it would work. And of course, there's not much here, right? But you probably could have guessed that you need to set up like the event listeners, like for the click, and for like looking for all these options that you put into this multi-select and handle all that logic in there, just like you would in an Angular component or in a Vue component. So the key takeaways here from the web component spec is that you get true composition, right? Get actual elements you can use instead of like virtual nodes or just a jQuery object or anything like that. And you're relying on low-level platform APIs. So this is stuff, just like we have Angular scope applying this scope styling, right? You don't need to do that here. The APIs take care of it. The browser takes care of it. And that's all good, but what about browser support? We're pretty lucky here because Chrome, Safari, and Firefox are fully supported now. Edge is working on it now, so it's in active development on the Shadow DOM and the custom element spec. So you still require polyfills for these now, and same goes for IE11. You can actually use them in versions below IE11 as well, but like with all these new APIs you're using, there's probably not. You're probably going to fill up the browser with polyfills at that point. So I would advise not to use them for anything below IE11, even though you could with polyfills. So that's basically it now, right? We know we can use it in our browsers right now. We've seen how it all works. But that's not a good developer experience, right? We're used to like Angular CLI, the Vue CLI, and we're used to having this templating languages and stuff like that. So that's the flavor part of my talk, right? Where we're going to go into here. I put names on them just so people could understand. Some of the, everyone should probably know Vue.js. We have Polymer in the middle. That's an old school player in this field, actually. I think if you use YouTube, it's built on Polymer elements, and it's quite old already. Then we have Angular Elements, which is an Angular package for creating web components. Skate.js, which is more over in the React world, has different renderers. It's pretty cool as well. And we have Stencil.js from the Ionic team, who was primarily an Angular team, actually, and have recently gone out and they want to break away from all the frameworks and just be sort of like in the middle. And we're going to go into how can you, as Angular developers, use this right now, right? So first, we install Angular Elements, the package. Then we create our component, and then we register it as a custom element, right? That's the steps we need to go through. And installing it is pretty easy. If you're using the CLI, you can do ng-add Angular Elements, and it will set up the package for you, and it'll also include some polyfills for you. Or you can do it depending on your project, right? You can just install it, npm install it as well. at that point, you would have to like look into this to the polyfills yourself, and there are different versions out there for you to use. Then we need a component, right? So this is a simple Angular component here. We have a class, we have an input of a placeholder, and as you've seen, I've actually commented out the selector, and that's because we're not going to use the selector, or we're trying to avoid naming conflicts, because we're going to register our Angular component as a web component. And as you saw before, when we do the custom elements define, that's where we actually give it its tag. One could say that, you know, it could be pretty cool if Angular just did this, and maybe they'll do that at some point, but they don't now. And then we have to sort of go into the next step. So this is out in our ng module, right? We include our component in our declarations and in our entry components, right? This is where, because Angular sort of needs to know, I need to be aware of this component, but I don't need to bootstrap it directly. Then in the module, we use this create custom elements function, and this create custom elements function actually comes from this Angular elements package as part of that. It takes your component and then and this options object where you can apply the injector, say if you're using your dependency injection in your code. And then we call the standard from the browser custom elements define, and this is where we apply the tag and our class, the class we get from create custom elements. And so what Angular actually does here in create custom elements is that it sort of binds the custom elements, like the lifecycle hooks there, to the lifecycle hooks on your Angular component, so it self-bootstraps. And every output you have on your Angular component, they are being bound as custom events as well. So like you can use them in everywhere in the DOM. And inputs as well gets placed as properties, so that you can basically just use it in the DOM. And it looks something like this when we use it, right? We have our multi-select and we have a placeholder. And this could have been just like any other Angular component, right? Only thing is that with this, we could use it everywhere outside Angular as well. And that's the next thing. What about outside Angular? Because I spoke to some here before as well, like, but the bundles are really big, right? Because you're bundling a lot of Angular with it, and that is very true right now. And I think they are aware of it themselves. This will hopefully change with the new Ivy renderer coming around. I know they've talked about like the size and how they can bring this down. But if you really want to try and see and use this outside Angular, there are tools out there. Manfred Steyer built this ngX Build Plus, which is actually has uses outside of these Angular elements as well. Basically means that you can extend the Webpack config that is sort of hidden with the Angular CLI, so you can extend that and do some custom things with it. Example here is that you could define some of the packages to be external, like Angular and stuff like that, if you had that globally, to decrease your bundle size. So that's sort of one tool you could use to bundle it outside of Angular. On the note of that, I wouldn't really use them outside Angular right now. And I know that's like we're talking about web components in Angular, and I really want you to start using them, right? But hopefully Ivy will change this. But say in your Angular applications, you could still get a lot of benefit out of these because they're self-bootstrapping. So say you have an application where users can input stuff like in a CMS, like, you know, with their rich text editors and stuff like that. You could put an Angular element, because it's a tag, just directly in there, and it will self-bootstrap. We used to in AngularJS, right? We could parse content and we could compile the components live in the browser, but that's ill-advised in Angular, right, to do this. But with these self-bootstrapping components, it gets a lot easier. As an example, I have a client where we have this dashboard, and they have like multiple applications they can access from this dashboard. And each application has like a widget or like a little key stat area that they can fill data into. But say, you know, one customer they only have 4 apps out of 8 active, and the other has all 8. So there's no use, there's no idea for me to load all that code in the dashboard. So what I did was we compiled them as like the widgets as Angular elements, and then we lazy load them if they have the applications active as well. So we don't like have all this code up front, but we only load them when the customers need them. In this example, when they have the applications active. So that's one use case for them. And of course, depending on what components you have out there, but building like a multi-select in there and then creating it as an Angular element, that just sets you up for the future, right? So if this whole thing with the Ivy makes them small enough for you to just distribute them in other frameworks, then there you have it. That's a pretty good use case. Onto Vue. I'm not a Vue developer myself, so this is stuff I read up on. I think it's pretty cool because Vue actually aligns pretty well with the spec, right? We create our component, our Vue file, and our Vue file is not that different from the file I showed before with the template, the styling, and the JavaScript code directly in one file, right? So they work really well with this. And then you just export it via the CLI. And it looks a little like this. Their CLI, build, target, web component, give it a name and an entry point, and it does the exact, well, not exact same thing, but something equivalent to what Angular Elements does, right? It binds up the event handling from Vue to the custom element and sets up the lifecycle hooks and all that sort of inputs and outputs to events as well. And then to use that, Vue sort of has the same problem as Angular, right? That even though you can build these web components, they still rely on Vue.js. So we still have to have Vue in there and a polyfill if you need that, and then your custom element, and you can use it directly in the DOM as well, just like the Angular one. What Vue has going for it though is that it's a lot smaller upfront than Angular is, so there's more use cases here. It's a little like, I think it's less than jQuery, right? And we have jQuery everywhere still, probably. A lot of people have them. And now we're going to go into another one here, Stencil. I mentioned all the ones before. I'm not going to go through all of them. I don't have knowledge of all of them, but they're pretty cool. Actually, if you want to look into Polymer with their new 3.0 version, like lit element and lit HTML, which I know Philip has talked a lot about. Indeed, yeah, it's probably on YouTube, right? So people can go watch it. But that's really exciting, the tag template literals. But since Stencil was, I think they released it, like they revealed it last year, actually at the Polymer Summit in Copenhagen, where they talked about it, right? This is the people behind Ionic, which is a what do you call this? A hybrid mobile app development, right? For building applications for iPhones, for Android, together with Cordova, right? To get native access, and they built this huge like framework around this. But Angular was getting pretty heavy in that they didn't really use that much of Angular. So they set out to look into this web components part, and they built Stencil, which is a compiler. Much like what Polymer does as well. So they compile down to native web components with a very tiny runtime. Stencil uses TypeScript and JSX, so TSX files. As Angular developers, probably a lot of you don't like JSX. I don't know if you've had any experience with it, but I know there's it's not for everyone. They have simple lazy loading built in. This lazy loading that we're actually struggling a little with in Angular, it's built in here. And it runs on this async rendering pipeline as well, so it's pretty performant. To get started, npm init stencil, at least if you're using npm version 6 or over, which will just fetch the component starter from GitHub and get you started. And this is a stencil component, and if I didn't tell you it was a stencil component, it looks a lot like Angular, right? Some of you might be like, okay, this is just Angular, except for like a few of the decorators here. And that probably stems from the the Ionic team from Angular. They really love this. They love the decorators and everything in there. So we have the component decorators. We have element decorators here to get the host element as your web component, right? Props for properties instead of inputs. Where it differs a little is this render method. So people coming from React will know this as well, where we just return some JSX here. So this is HTML directly in JavaScript with types. And I got a little teaser from the dev team at Stencil that they're building on. Work in progress, disclaimer. But this, and I know Hello World is not the best like view on how you build applications, right? But we're talking about a Hello World component here, broadly compressed at like 250 bytes. So that's pretty good for performance, right? And they have a runtime around 6 kilobytes that includes the renderer as well. So I think we're getting there compared to some of the sizes we've seen, especially if you're trying to bundle out Angular components. And that's sort of what I had. So are there any questions in relation to anything I've talked about here? Anyone?
So with the scope CSS in web components, one way to get around it is to use CSS custom properties. So native CSS variables.
Yes.
So you can allow customizing some parts.
Yeah.
Of the styling of your web component.
That's correct. Yeah. Yeah.
Also, I want to mention that Ivy will probably not be in Angular before at the earliest version 9 of Angular. Igor Mina said that in Angular Connect. So that's a bummer for web components.
Both yes and no, yeah.
And about the lazy loading you mentioned,
yep.
It's kind of it's not there yet in Angular. It's not. You have to go through the router.
Yeah, that's correct. Yeah.
Change that as well.
Yeah, I know.
Support dynamic import statements.
Yes.
For lazy loading. That's pretty awesome.
Yeah, that's pretty cool, and that's definitely going to help. That's correct. Yeah. Yeah.
Is there a limit of the complexity of web components?
In what term?
Well, you showed a multi-select, and that's not exactly a complex element.
That's correct, yeah.
Date selector is a bit more complex. Is there an upper limit, or is it just?
It's like what we do with Angular, right? You could put like an entire date picker in one component if you wanted to do that. Yeah, your web component could also have, web components inside of it, of course. I don't know if there's any upper limit. I don't think so. It's really about what you build. But of course, if you want to keep, a size down, that's one thing. And web components, because you can use them like everywhere across the boundaries, right? You have to think about how people use them a little more than, if you build an Angular component, it's probably going to be used within Angular, and you have these constraints, right? But with a web component, it can be, used just directly in the DOM. So you have to sort of think like, what is your public API on your component? So I definitely wouldn't build overly complex components directly as web components unless they had a specific purpose and a well-defined API. So yeah. Great. Just remember, be responsible. And this is actually, this covers components as a whole, right? I mentioned the multi-select and date pickers and stuff like that. But what I'm thinking about here is accessibility. Because when you're building web components, you're introducing these new DOM elements out in the world, right? And like, don't try and create a new button. Like, just use the button that's there. It's very accessible and it works in the browser, right? And if you really have to do something that sort of mimics a native control of any kind, then just remember to make it accessible and make it usable, because that's going to improve your adoption rate of your components out there. And then analyze key candidates for web components in your projects. Now you might have some candidates already that you can start working on, and then start building with the platform, not necessarily just on it. Just use it.
So you mentioned, you mentioned buttons.
Yep.
There's this syntax where you say button is my button. Does that work now? Or is it discarded?
It's not discarded, but Safari has said they're not going to implement it. So there's no use in doing it. But that's correct. You could actually extend built-in elements and use those.
And the is attribute thing is, for that reason, not included in the polygons.
Yeah,
yeah. You don't want people to start using it because it's probably never going to end.
Yeah. Actually, the guy behind the polyfill document register element has it in there somewhere. Like, he's very big on keeping it small and backwards compatible. But that's a whole other talk. But yeah, that's correct. You could extend it. Yeah. If you only use Chrome, you could use it now if you wanted to do that. But I don't know who can say that to their customers. Don't use anything else. It's just only way here. So. Great.
Excellent. Give it up.
That's what I had.
I think the drink is just about to be hot. So go for it. We'll start back up when I start crowded streaming.
Hello. Tonight's topic is about my painful experience with dirty code and how that led to a step-by-step process to make it clean again. A three-step process to make it clean. So before I start, let's talk a little bit about myself. I'm a freelance full-stack developer. I have a background with AngularJS back from the day, and .NET development, and I also do some DevOps. So I do a lot of different stuff, but Angular development is my primary stuff I do. I also have a blog where I blog mostly about Angular development, so go check that out. I blog almost like once a week, so you can check that out. And my GitHub for mostly also Angular code. And go follow my my Twitter, where I will come with updates. So let's start with a couple of hands up. So hands up, who thinks refactoring code is important? Hands up. That's a couple of people. Who is allowed to spend time on refactoring by the client or boss? We like doing 50-50 here. That's interesting. And who has code that needs to be refactored? All right, everyone, hands up. So that leads us to this topic of the day. And let's look at the real motivation behind clean code. So the thing is that should you optimize for getting the code done as fast as possible, or should you optimize to make it clean and intentful and communicate what it's doing? So code is read way more than it's written. So that's why you should definitely optimize for keeping it very clean and read optimized. You want to optimize for clear and effective communication. And this talk is going to go in depth with how you're going to follow a step-by-step process to keep it clean. And we're going to go to the code level to ensure that you keep the code clean. So let's look at why does code rotten. I'm sure that no one has made the plan. Let's make this component 2,000 lines, and let's call the variable x and y, and let's not understand what's going on anywhere. I think no architect will plan that out. So why does code rotten? And from the book Clean Code, there's this metaphor of the broken window. If you see an abandoned building, the point where people just completely lose respect of that building is when the windows start breaking. That's like when it hit this critical point where it's like there's like no respect for the building anymore. It's like full of graffiti and people are even just stealing stuff without even caring because it's completely broken anyways. So it's the same thing with code. You hit this critical point of dirtiness in your code, where people don't respect it anymore. It's like, but look at this other code. It's completely, it's completely dirty anyways. So why should I be the one who is doing all the hard work and making this clean all of a sudden when we have like 10 years of legacy code behind us? And the real motivation is bad code kills. Actually, we have this accident with Toyota that has an accident where the fail-safes, the thing that is controlling the acceleration, broke. And that was due to spaghetti code. So there you have it. Your bad code might kill somebody one day. And let's look for why is there still, if it's so dangerous to make bad code, why is there still much bad code? If you start a new project, you can almost expect that there's going to be a lot of some bad code, or some it depends on where you're coming from. But yeah, there's also going to be always going to be some legacy code, and this is the objection that I tend to hear. First of all, let me see. First one, I'm just going to do this later. Oh, I'm really busy right now. I'm just going to do this later. I'm going to have time later. And the thing is, you never have time. You never have time. You think you're going to have time after this big release. Now you have time to make it all clean and make it all good again. But guess what? It's never going to happen, and the best thing to do is to prevent it to get dirty in the first place by incorporating this in your daily work instead of just having this big refactoring job at the end of a release. You have this cycle where you have a very quick release, and then things just start to go slow because now you don't understand the code anymore. It's full of bugs, and you change something one place and it's breaking the other place. And the other thing is, my boss won't allow me. You maybe have a boss that won't allow you. You're not allowed. Also, like 50% of people here were not allowed to refactor or any objections like that. And my response to that is that you should be faithful to your craft, just like a lawyer and a builder and a doctor would. If you go to the dentist and be like, "Can I get this a little cheaper?" Maybe if you just don't clean the equipment. Can I get this a little cheaper? Because I don't want to pay for all that. And if you just want that, he will definitely, if he had any respect for his job, he will say, "No, this is how I work. This is my craft. I don't do that. It will have all kind of side effects on you if I were to do that." The same is with dirty code. If you do bad code, you're gonna create all kind of side effects in the code, and it's like your job to communicate and be like, this is your craft, and stand up for that. So now we come to the Angular specific, my 3-step process of refactoring an Angular. When I come in and I see it's very dirty, this is my secret weapon. Well, now it's not really secret anymore, but you can have it too. This is 3 steps I go through. Normally, what I start seeing is I see 2 big components. I've seen components with like 2,000 lines, and they contain all kind of different logic. It's business logic, it's all kind of stuff. And it's all one big spaghetti. You don't know what belongs where. So when you look at the code and like, oh, what's this part belonging to? I don't know. But it's just these big components. Then you want to break these components into what's called smart or dumb components. There's some different names for that. You can call them container or presentation components. I like to call them because that's what it is. We have the containers that is delegating and controlling, and then we have a presentation that is containing presentation logic and it's showing the actually presentation. And after that, you want to delegate. You want to slim the components down as much as possible and keep the logic inside of services. So what I like to do is I like to put it into what is called, you know, from MVP pattern with these presenters containing logic for the components. I also like to call them just component services, dedicated services for a component. And then they start to become too big. I make the critical point at around 500 lines of code in the services, and then I break them up again to smaller services. So this is like my process, and this basically I do it all over, and it's an iterative process. You keep doing this, and you don't like try to plan ahead. You just do this when you run into trouble, when you like hit the critical point. Oh, now it's hard to work with this component again. Then I'm gonna follow the step process, and eventually it will be all good again. I've seen very hard cases that have been fixed by this, so it works. The first step is you gotta split this. You have a huge component. Let's say it's 2,000 lines and containing a big template containing a lot of logic inside of the component, and you start splitting these up. So you have the container part that is doing injecting services in. This here you're delegating for the HTTP calls and injecting other services in. And then you have a presentation part, which is called, which is containing input and outputs and contains presentation. So it would look something like that. For example, for a blogging application where you have the container part here. Container part is doing the injection of the services. And then you're gonna have all these presentation components that is communicating with inputs and outputs. And also one thing I thought, if presentation is dumb component, does that mean that UXs are dumb? Are there? So let's look at a container component. We have a container component here. You can see it by that it's injecting a service. So it's doing some kind of delegation here. And it can contain inputs as well, but it's delegating. That's the job of this component. And you see here that I'm also doing this view providers setup here, where I'm hooking up the dedicated service that is containing all the business logic for this component, so we can just delegate and keep this very slim. And when I look at this, it doesn't take a lot of time to just see what's going on. It's very easy. When they have the presentation component, we have the change detection. That we have the benefit here, but we can do change detection on push, and that is because we only have inputs and outputs. And that's how if you do on push, you will limit the amount of renderings this component will have, because it's only going to render if the input is going to trigger a new reference, and if you're going to do some event inside of this component. So it can be a performance boost to have this set up here. And yeah, you're gonna delegate. You're gonna move outputs up to the container component, so it can handle the save logic. It can call the SSP service and do all that. So the next step, when you have these two split up, you want to create these dedicated component services to just slim down the components, just make them as small as possible. And you do that for container components, and I also do that for presentation components. And you can argue, is it still a presentation component? Well, you don't do it. You're only delegating the presentation logic, just again to keep it very small and have a clear split of what is like the control mechanism, and what is like more the business logic part. And then the last part, when your dedicated component services are getting too big, you want to split them up into smaller component services. And then it's up to you what kind of split you want. It's kind of a creative decision to how you want to slice the cake, because it's not that easy all the time to find the slice. But when you get too big, you'll find some way of slicing it up. And I see it around 500 lines of code, then I'm starting to look into how I can slice it up. When it exceeds 1,000, I'm definitely going to look to slice it up and move the logic to a more central place where the logic should belong. So let's look at how this is done for an example. Here I have my to-do app application. You can complete stuff. You can. It's Danish. You can change the language. You see it here. So it's a pretty simple app, but it's to demonstrate how this process works. And you can see how the old architecture of the app was, where we had this kind of big component here. It's not that bad because it's a simple app, but it is to demonstrate how this might grow into something you don't want to maintain and make it nicer. So the first thing is we have this big component in the refactored edition. Now we have this. It's turned into this now, where we took all we looked at all the parts and made a decision: does it belong to presentation or does it belong to some delegation logic? And if it's presentation, it's going to go down here. So it's going down here. We slimmed down actually the whole template, so it's just delegating all the way down here. And now it's containing the template here, and it's going to do on push here, because it's very easy to set up here and ensure that we render correctly when these inputs changes. And yeah, the next part is that once this happened, we still had kind of a lot of logic here in the component. We want to slim that down even further. So we see that I'm delegating everything to a dedicated service, and I do that with view providers. And there's providers and there's view providers, and the benefit with view providers is that I don't want like content children to be affected by this. I only want what's inside of this, including view children to service to provide for. And what's going on here is it's delegating everything. Everything you saw here, it's just delegating. So the thing is, when I'm looking at the logic, I can just look at it here, and it's very, very clear what the use case is doing. When I want to look into the logic behind, I go in here, but I don't need to be cluttered by the logic all the time. I also did this here where I had the same case. This is pretty much too small to justify to split it up in container components and presentation components. But if it grows, I might do that. And then the dedicated service is going to contain some of the logic. Again, it's very simple here, but that's just to ensure that it scales. So let's look into refactoring on the code level. So there's two good books I would recommend. I saw you had the clean code cheat sheet over there. It's very good. It's very good to just look up and know what you're doing wrong. I would recommend this one definitely, and clean code is also good. They have some clear principles around how you should structure your code on a very code level. Not as abstract as just the solid principles. This is really goes in depth with how to do it. And I want to incorporate this knowledge into some important points about what you can do now to write cleaner code. So as you know, you should optimize for readability, and it's kind of the same thing as the CQoS pattern you see on the back end, where you optimize for faster read performance because and web app is doing more reads than writes. So it makes sense to optimize for the more used operation. Same thing in code. You're just doing a lot of read, you optimize for read. And if you need comments to explain how the code is not clean, so if you need to, you see a big block of just explaining this is going on down here, then you know it's not clean, and you probably just should refactor it. But if it's like this is a hack, this is why this is doing. I know this is a little weird. This is why this code is happening here. That's totally all right. That's why, and that's what comments are for. And the brain can only contain around 7 things simultaneously. So you want to optimize for that. When you look at a method, you shouldn't have a big cognitive overload for having a lot of different things at the same time, and juggling at the same time in your head. So you should limit this to around 7 concepts in each method, in each class. This is like the level of abstraction. If you get more, you just break them down, so it's at every time it's not more than that to work with. And then the 3 seconds rule is, when you look at a method and you look at a class, it should be so self-explaining that you don't need more than 3 seconds to just know what's going on. So the third thing is self-explaining method names. And a method should just explain what it does without needing to look into the code. Again, if you need to look into the code and go white box with it, then it's something bad. And you either explain what it returns or the side effect. I'm going into that later, the command query segregation, why you should split that up into 2 parts. But when a method is just user, I have no clue what's going on. Is it going to create a user? It's going to get the user, get user ID. Now I know. On change, it's like, I don't know what's going on. It's probably something that's written very fast. Username update, if it's not like that, I know what it is. And it's just communicating either what it's returning or the side effect without a need to look into the code. Then the command query segregation. This is related to well-named methods where you want to keep it very separate if it's querying or if it has a side effect. And let's look into what's a side effect. Well, a side effect is then the method is changing some external state outside of the method. So every time you do that, you don't want to call a get method, and then that get method is gonna change some external state. That's gonna be confusing. You're gonna be like, I don't know what's going on. I don't feel safe about this code anymore. So, for example, if you have a counter here that says get next count, and that's increment the counter +1, then you need to look into this method to know what's going on, and that's bad. So instead you split them up into something like get next counter, and then the command here that is setting the next counter. Having this set up, it just makes it easy to see, And where do you think the most errors happen? Is it in the querying of stuff, or is it in the modification? No, it's in the modification. It's when you query it just call an let's say you call an HTTP get method. Nothing bad can really happen. You can call it 1,000 times. Nothing bad will happen. But when you start modifying stuff, that's where the errors tend to happen. So if you have that clear, then you know where to look when you need to debug stuff. Oh, we have this method that's modifying the state. Now I'm going to look into that. And self-explaining variable names. A variable should explain the value it holds without any ambiguity. Also, you tend to see stuff like as short names that don't really make sense. You see something really bad like X and Y. That makes definitely no sense. And so if you have some user ID, you could say a bad example would be user ID or UID. UID maybe if it's a very common shortening of the word, or otherwise you wouldn't know what's going on, so you might just stick with some explaining variable name. It'd be very easier, especially for new people on the team. They can just read that, and it's going to be very easy to know what's going on. And then a consistent level of abstraction is very important, and that's the 3-second rule I talked about before. So to obey that, you need to have a consistent level of abstraction. If you work very low level, if you look at like an assembly program, it will take a lot of time to know what's going on because it's way too low level. So you want to keep it a consistent level of abstraction where for every level there's around 7 concepts. It takes a maximum 3 seconds to know what's going on. That's how you want to break it all up. And you can have it like here where you start doing some use case method here, and then you do the HTTP client directly, or you could do some WebSocket directly, or something more lower level. If you mix that, then what's else? Well, there's gonna be a lot of like lower level stuff here. It's naturally gonna grow too big, and it's gonna be inconsistent. You're gonna be confused. Why is this use case method being called here, and then we're going lower level here? So what you want instead, if this you see this, then when you need to wrap this into some equivalent level of abstraction that is equivalent to the use case levels here. So if this is a use case level method, you want to make this a use case level method and just take all the lower level code and move it into some use case. If it's low level code, you want to take keep it pure low level code. So in Code Complete, there's this 3-step process of writing clean code. And the first step is that you start with writing pseudocode as comments before writing the actual code, which will just make you abstract a little bit away from the actual code and just think about the use cases. Do this, do this, do this, very simple. And then you replace the comments with equally well-named methods. You should not lose any meaning from the methods. I think it's okay sometimes to keep the method a little longer if it actually explains what's going on. If it just keeps it short, because I don't want that long, it's too wide for my screen, I don't care. It should explain what's going on. And then you should implement the method using the above guidelines, using a consistent level of abstraction, command query segregation, and such. And then one last thing is regarding refactoring style and formatting. Some people are very religious about the tabs versus spaces and all this style stuff. And my opinion is that if it can't be automated, don't even bother, because it doesn't really matter. The only thing that matters is that it is consistent. And you just decide on something and just roll with it and just keep it consistent and just use some formats. So like if you search T.S. Flint and Pretty, you'll probably find my blog post where I show my setup of how I'm setting this up to make it work together. And this is just, you just save and you just format in VS Code, and it will take care of anything. So before, when you need to like fix tabs and stuff manually and fix either you use double quotes or single quotes, now you don't need that anymore. You just follow the automation. That's what I have for you. Do you have any questions? Yeah?
I have some input regarding the writing the pseudocode in comments, I actually, if possible, I like to start with a test, and I actually write part of the logic that I can in a unit test, and that, for me at least, it's enough to start to make the code that passes my test, and then change my test to expand on the business logic, and then change my code and so on. As it's test driven.
Yeah, you can definitely mix this with TDD. You can do the test first, then you can do the comments to just ensure that it's going to be very clear, and then you can just fill out the gaps. And you don't need to do this like all the time. You do this when it's maybe getting more complicated, and you still want to ensure that you're keeping stuff simple, because that's really the key here, to keep stuff simple. If you start doing it too hard for yourself, a lot of applications there are actually pretty simple when you look at the basic business logic, but it just made very complicated with all kind of by violating all these rules, basically. Yeah.
You talked about splitting big components into more small.
Yeah.
Could you end up having a lot of components and then quite a confusing project structure, having a lot of files, the TS, the XML, eventually
So as you saw in the demo, I'm not going to do this like a robot that's going to do it without thinking. I'm going to do it when it hurts. And so when I see a component get too big, that's when I'm going to chop it up. If a component is like 20 lines, it's going to be a big hurdle to start splitting it up and stuff. I agree. So you want to be pragmatic about this. Yeah.
So do you ever consider, you had a slide where you talked about smart and dot components or presentational container components. And there was on the slide it said a container component and a presentation component. Do you ever consider doing a container component with several presentation components, so they're reusable, the view part of them are reusable?
Definitely. So when I have a lot of these, I'll probably have a lot of these in the shared components in an app. You'll probably have a lot of these, and you want to keep them presentation component, keep these separate, because as you said, it's way easy to reuse. If you have a lot of, you're gonna do a lot of Redux stuff inside of there, you're gonna make it harder to reuse. If it's just very bare bone, it looks like this, and you have to take these inputs and outputs. It's very easy to reuse. So yeah, definitely. But again, the reuse part is something I'm gonna do later. So it's like when you refactor everything else. When you see you start repeating yourself, that's when I will move it into the shared. And then I will ensure that it is a presentation component. I can just use both places. But yeah, when it hurts. Yeah.
Also, a table would be a good example where you could have one container component for the state that kind of let the state flow down to all of the cell components and row components and the main table components. I'm curious, Christian, could you point out a place in your code where you think that a use case is the most identifiable, with the highest level of abstraction in your example app there?
Highest level of abstraction is going to be at the container. So it's going to be like this: delete a to-do item and edit a to-do item. That's pretty high level. I guess that's like the upper level. That's the use case. If you were to do the use case diagram, that's how it starts. And when you look at the component, I just want to make that crystal clear that this is the use cases. And then if you want to look into the business logic, there's the service. And you want to look into the presentation, go to the presentation. Yes. Anyone else?
Excellent. Give it
That's
up.
it. There you go.
I guess that's it for today. Always good to see everybody. Hang around a little bit if you'd like. Help us clean up if you're a good guy or girl. This time we don't have a date for the next meetup, so if not before, we'll see you at NG Vikings, but hopefully we'll do a meetup before. But on another note, Morten and I have been talking about whether we should merge ngAarhus with Aarhus.js and make it more of a broad widening of all the frameworks and all stuff JavaScript. So come, I see some people nodding, but come talk to me about it and tell me what you think. If it's a bad idea, if it's a good idea, we might do that for next year. But we haven't decided completely yet, so come talk to me. But good to see everybody, and thank you. And I think we're 3 for 3 for videos today.